Hello everyone. In this video, I'm going to continue to use the reference 1 to 5 to do some examples for you. In example 4, you have point ABC lying on the circumference. You have point N and M on AC and AB respectively, so that ON is perpendicular to AC and OM is perpendicular to AB. And also OM and AC intersect at D, so that AD to DN is 3 to 1. And you're also given some lengths here. ON is 2 and AC is 12. Now first of all, you need to show that triangle OMD is similar to triangle AMD. Now to do so, you need to recall which reference you want to use. We have 3 reference to conclude a pair of similar triangles. One is the 3A, one is the 3 sides proportional, and the remaining one is the ratio of 2 sides included angle. But most of the time, if the lengths are not given, then we will just consider the 3A. But here, you have lengths given here, then it may be related to the remaining reasons, 3 sides proportional or ratio of 2 sides included angle. But anyway, we will first consider the 3A. First of all, we know that ON is perpendicular to AC, although in the figure it is the right angle is drawn as angle ONC. But then look at the question here. Okay, the content here said that ON is perpendicular to AC only, so we can write whichever side we want. Okay, so I can write ONA is 90 degree. And also, OND, triangle OND, and triangle AMD have a pair of opposite angles. And these 2 angles are equal. So we have 2 pairs of angle equals, and that's enough for us to conclude a pair of similar triangles. So part A, we can do it in this way. We will write angle ONA is equal to 90 degrees, which is given, and angle OMA is also 90 degrees, which is given. Then angle ONA is equal to angle OMA. Okay, this is the first pair of angles. The second pair is that angle ODN is equal to angle ADM. Is the vertically opposite angles. And as long as you have 2 pairs, you can conclude that the 2 triangles are similar. But then at this stage, you can write the pair of remaining angles like this. So we have the remaining angle, angle DON should be equal to angle DAM. Okay, it's true based on angle sum of triangle. Okay, so it may be a little bit weird for you to write 2 angles equal, but then the reference is the sum of 3 angles equal 180 degrees, right? But then later on, you can omit this step. And in the proof, when you include 2 pairs of angles equal, then automatically, based on the angle sum of triangle, you will have the remaining angles being the same, right? So this line is a little bit informal, but then later on you can just omit it in your public exam. Okay, so you're allowed to use it here like this. Okay, so therefore we have triangle OMD similar to triangle AMD based on the reference AAA. Okay, so this is part A. Now part B, you need to take care of the length. You need to find the length of AB. And you know that if you want to find the length of AB, you just need to find the length of AM, because M would be the midpoint of AB. And we'll need to see what we have here. We have ON being 2. We have AC 12, that is AN and NC are 6. And AD, DN 3 to 1, so I can have AD, I can have DN. And of course, I have a pair of similar triangles, so I can use the corresponding size to find it. Okay? Because I have the DN, the corresponding size of DN would be AM. And the corresponding size of AD would be OD. So we need to use Pythagoras theorem on triangle OMD. Okay? So let's start. To find the, we need to first draw the length that ON is equal to NC. Okay, since ON is perpendicular to AC, so AN is equal to NC, and it's actually half of AC, which is 6 cm. Okay, is the perpendicular joining center from center to chord bisects chord. And then we have AD to DN is 3 to 1. So I need to have both AD and DN. So AD is 3 over 3 plus 1 of AN, which is 4.5, isn't it? 3 times 6 over 4, 4.5. And DN is AN minus AD, which is 1.5 cm. Now we still need to have OD, because I would like to have the corresponding size, right? So in triangle ODN, we have OD square equals DN square plus ON square. The Pythagoras theorem. And DN is 1.5 and ON is 2, which is given. So you should have OD is 2.5 cm. Now, since the two triangles OND and AMD are similar, proved, and so we have AM over DN is equal to AD to OD. Okay, it's the corresponding sides of similar triangles. And now we should have, let's write it here. Now we should have AM is AD, which is 4.5, divided by OD. OD is 2.5, multiplied by DN. DN is 1.5. So AM is 2.7 cm. And so AB is 5.4, but then we have not yet written AM equals to MB. So this is the final step. Since OM is perpendicular to AB, which is given, so AM is equal to MB equals to 2.7 cm, and is the perpendicular joining from center of chord bisects chord. And that is AB is AM plus MB equals to 5.4 cm. Okay, so this is example 4. Is a little bit long because it involves a proof and the use of Pythagoras theorem and the use of similar triangles. Okay, so it's a little bit long here. Okay. Okay, before the end, we discuss one more example. This is example 5. Example 5 is actually a simple problem, but since I want to use all 5 references through all the examples, so I include this example here. Okay, PQ are centers of 2 circles, and 2 circles intersect at AB. That means AB are both chords of the 2 circles. Okay, M is a point on AB, so that PM perpendicular to AB. Then we know that BM and AM are of the same length. And then the question is, does PM produce pass through the center of Q? Now, if you produce PM, then the line PM and its extension would be the perpendicular bisector of AB, and AB is the chord of the circle with center Q. Okay, and finally the answer should be yes. Okay, but then we need to write everything down, including the correct reference. Now, since PM is perpendicular to AB, which is given, and so AM is equal to MB, is the perpendicular joining from center to chord bisects chord. And now let's draw some line. Okay, we extend PM to say meet the circle on the right at another point R. Okay, so we write it down. Let R be a point on the circle with center Q and is on the right of Q, such that PMR is a straight line. Okay, one reminder for you is that you can also say here the 3 points P, M, and R are collinear. Okay, you should have learned this word in Form 3, so just a reminder for you. Now, just argue something. Since AB is a chord of the circle centered at Q, also PR is the perpendicular bisector of AB. Therefore, Q lies on PR. Okay, then the reference is the perpendicular bisectors of chord would passes through center. Okay, so this is example 5. I just want to use this reference perpendicular bisector of chord passes through center. Okay, that's all for this video, and there are 2 more examples coming up for reference 4 and 5. Okay, stay tuned and thanks for watching.